Welcome to part 2 of this brief overview of some of the practicalities of designing for and using a laser cutter. We left part 1 having designed our particular object in carefully planned layers. We will now pull much of that apart as we get the object ready for the laser cutter. We could, of course, simply show only the layers from a single sheet and export that to the laser cutter and cut it as it was drawn. But this would be enormously wasteful of material and, as we have seen, not an inexpensive material. But in addition, the layers we carefully plan for the design of the object are not necessarily suitable for the cutting process itself, as we shall see. In practice, we'll tear up the drawing, well, actually copying and pasting to a new set of files. I can guarantee you'll need to go back to the original at some point, to create a file for each thickness we have used. Do this by showing only the layers pertinent to a particular sheet, hide the rest, then copy and paste this, including any etch layers, to the new drawing. Repeat for any other layers referring to sheets of a similar thickness. At this stage, don't worry about the layout in the new drawing, just ensure they don't overlap. You lose nothing by having them well spaced out, and it makes the next step easier. You do not need to copy any construction or annotation layers. This does highlight one useful tip, which I'm sorry to say I don't always do, and that is to use the thickness of the material in the name of the layer. One thing I do always do, however, is include the thickness of the material in the file name. If you are cutting several sizes in one go, this can be very helpful. It may be that, if your building is big enough, you will need to later subdivide these into multiple sheets, but there's no need to worry about that at this stage. The primary task at this stage is to use the material to the best possible advantage. Here is an example from my first building. I'll cover some of the issues shown on this slide in a moment. And yes, I know there are 5 bits of roof for a 4-sided building, but adding spares where you can is no bad idea. The key dimension here is the maximum size of the laser bed. That is the maximum size sheet that the laser cutter can cut. Clearly, this is a restriction you have to work within, and its influence will vary depending upon the scale you are working in. The club laser I use has a bed approximately 450 by 350 millimeters, big enough for most things in 4mm, no problem in 2mm I would imagine, but you may need to make buildings in sections in 7mm. Setting the size of the grid, as we saw earlier, to this size gives a very simple visual indication of how your design will fit on a sheet of material, and if you need more than one sheet. If your software does not allow setting the grid size, then add a rectangle on another layer and use that. Just remember to hide it before you export the drawing. There are, however, a number of other issues that you will need to consider in laying out the drawing for cutting. The first I'll look at is tabs. To have tabs or not to have tabs is certainly a question. To state the obvious, tabs are there to keep the final output together, as you can see in this drawing. I see 3 reasons. One is to keep the cut parts together once they are finished, which is nice but not essential in itself. And the second and third are to avoid problems whilst cutting and are far more important. Your laser cutter will sit on a grid. The club laser I used is a simple vertical grid, but others might have a honeycomb or square grid. Small parts can fall through and, whilst this is not disastrous as they can be retrieved from the offcut tray below, can be tedious. The bigger problem, however, is that they might half fall through. They tilt across a grid bar, but do not fall through. This can be disastrous as the piece sticking up can catch the laser head as it moves around, which will move the material and ruin the job. So, if your part is large enough to cross more than one bar of the grid, it can probably be left untabbed, unless it's an unusual shape. But otherwise, you need tabs to hold the parts level. Tabs need not be big. I typically use 0.5 millimeter and also put etch lines across where the tab joins the part you want. This makes it easier to separate and clean up afterwards. I said there was a third reason for tabs. This is more complex, And it's not just about tabs, but they are part of the solution. It's about keeping the parts in place whilst the laser is cutting. The laser will cut the layers in the order you dictate. You should always do the etch layers before any cutting layers. But within any layer, the laser cutter will cut in an apparently random fashion. It's obviously not, and it appears it's probably the order the objects were originally drawn in. But for some things, you need to keep a tighter control on where the laser cuts and in what order. I'll highlight windows and long thin cuts. You can see in this part of a cutting plan that I have created a number of additional layers for this particular sheet. There are horizontal and vertical etch layers that produce the brickwork, etc. There is a cutout layer that provides the main cuts. There's also a last cut layer that I will touch on in a moment. But also I have separate horizontal and vertical cutout layers. These are for the windows and allow me to force the laser not to spend too much time in one place. Typically, I draw my glazing bars 0.6 mm, allowing for the 0.2 mm that is lost to the width of the laser. This gives, in 4 mm, a scale 1.2 inch glazing bar, which seems fine. If the laser does all the cuts at the same corner, one after the other, the narrow material can buckle with the heat. The separate horizontal and vertical cut layers for the windows help avoid this. Long cuts on narrow objects can also cause problems, particularly on thinner materials. Given that some heat is always generated, you can probably see that these long strips have a tendency to buckle slightly as the cut is made. To minimize any risk from this, I manage the order the cuts are made in. As always, the etch layer should be done first. Then I cut any mortar return holes, place them in their own layer to allow this to happen. It's probably worthwhile doing this in the design layout in the first place. It saves a lot of hassle later. I know this because, well, let's move on. I have a layer that cuts out most of the strips but leaves some large temporary tabs. In some cases, you may want to make some normal tabs as well. I've removed the normal cuts and you can more easily see the red lines which are my temporary tabs. You'll notice that the ends all fall into this layer as well as some along the length. Precise sizes aren't important, just enough to hold things in place. The last thing to mention here is what I usually call the last cut. Just for a change, this is from an underframe for a converter or transporter wagon to take standard gauge trucks on a narrow gauge wagon. And I realise that the picture is the first attempt and the drawing is the revised version. You can see that the drawing has a black outline that provides the frame. If you're going to tab everything, then this makes sense. If not, then it's not always worthwhile, but it's a personal option. As an aside, text won't etch or cut unless you convert it into an object within your CAD program. Here's a summary of the key points. Now we'll move on to look at how you take your laid out cutting design to the laser itself. You will need to export your design to a format that the laser cutter software can understand. There are two file formats it's likely to be: DWG and DXF. DWG is a proprietary AutoCAD file format, but it can be licensed by other CAD vendors. DXF is also an AutoCAD developed standard, but its interface is published, so other vendors can develop interoperability with this standard. In my case, this is a DXF format. It's also worth noting that these both have new versions released on a very regular basis, so not all older software is compatible with the latest versions. You will have to experiment to find what works for you. You would think that having drawn something in a colour, then it would be that colour, right? Well, not always. Objects you draw carry two colours: the colour of the object and the colour of the layer. Let's look back at the simple net we saw earlier. Green lines are horizontal etch, brown lines vertical etch, and the blue lines the cutout. Unfortunately, some software, including both TurboCAD 2009 and the LaserCut software we use, default to using the object colour and assuming that all objects the same colour are in the same layer. If we turn the layer colours off, we get, when we tell our laser software to etch the green and brown layers and cut the blue layer, we're going to get a very different object. The software can be set to take the layer as the key, but has to be told to do so. It's an easy problem to have. You might at this point choose the option of sending your file to a commercial laser cutting service, of which there are many. They will be able to advise on the specifics of file format, layer colors, etc. But I'll proceed on the assumption that you have access to a laser cutter yourself. Having got your file in the right format, you'll load it into the laser. But don't. Do a test piece first. Doesn't matter what it is, something small, but something that includes any key features, mortar returns, window panes, tab and slot joints, etc. It's well worth the effort. You will now set up your laser software. Obviously they all vary, but I'll cover a couple of important points that are fairly generic. The first thing to notice is that this hasn't been corrected for layers, so if it was cut like this, you will get entirely the wrong result. There are three things that govern how the laser cuts your material: power, speed, and a number of passes. The more power and less speed, the more powerful the cut, and vice versa. You can see here that the top three layers are set to etch, the last layer set to cut. The speed and power combination tells you this. The number of passes is set to 1. This is something you might increase if your laser cutter is struggling to cut a particularly thick piece of material. But they all say cut, I hear you say. Well, yes, but again, confusingly, an etch for the laser software is not the same as an etch that we've been discussing. Etches are, as far as we are concerned, simply laser cuts with less power and/or greater speed. The mode column can be set as etch, but an etch for the laser is to do with etching glass or metal and not something we are concerned with. Everything we do is a cut as far as the laser is concerned. I've never had to use more than one pass for a cut, but then a club laser is an LS3050, which is a £3,000 plus machine second hand, so pretty powerful. Typically the power setting versus the depth of cut is linear on a laser up to about 70%. Above that it starts to fall off as the extra heat melts or burns the material as appropriate rather than cutting. And anyway, lasers have a current limit for continuous usage, and most recommend that you don't go above about 70 to 75%, as it surpasses this limit and also wears out the laser. You will have to try the combinations of power and speed on the material of your choice. As noted before when discussing window panes, it can be helpful to keep the power down with a slower speed if you need to reduce the heat in a particular area. Bear in mind also that to cut the datum wall of the warehouse I've used to illustrate some slides will take an hour or more, mostly doing the brickwork. You will need to adjust the laser head carefully to the correct height. Ironically, it's easy enough to cut some simple gauges with the laser cutter if needs be. Our laser also has a useful test feature that allows you to check that the cut you're about to make will fit on your piece of material. Just let's look at some examples at various stages. The warehouse I've used often as an example has an MDF internal structure with plastic card overlays. The parts I've been using are the left-hand wall overlays as we look at this. This is built in 2mm MDF with 3mm MDF roof. Here are the parts for that wall, 85 in total. Not all have been cut out in this picture. It is, like any etch, worth keeping delicate parts attached until you need them. And here's the gatehouse, not yet finished or actually stuck together, with the warehouse in the background and other mock-ups on the layout. I hope you found this presentation helpful. The hardest part is, unless you have previous CAD knowledge, getting around the CAD software itself. For the rest, it's straightforward enough once you know how, but there are several steps that are impenetrable without help, and it's those I've tried to address. Have a go. It doesn't all have to be railway related. I will close by passing on my thanks to the fellow members of Risborough and District Model Railway Club who have provided advice and suggestions along the way, and to James Aitken in particular for all his help. Good luck and goodbye.